Good morning, students. Today we are going to take up the class on types of inventory situations which are to be in the inventory management system. So, what are the types of inventory situations means? Order repetition, demand distribution, stability of demand distribution, and demand continuity, lead time distributions, dependent or independent demands. So, why these are the situations are arised means inventory is those stocks or items used to support production. So, supporting activities and customer services, either by finishing goods or spare parts. This is the definition coming out from American Production and Inventory Control Society, which is a society that plays a wider role and influential role in the inventory management area. And each of the 6 classes of inventory situations that are described to be its own type of management, even though they can all the centralized or decentralized according to the dispersion of use for the producers or suppliers and customers. Then coming to the first situation is order station. To explain the order situation, there is a static inventory models have no repetition. In order, we are having two types, that is static and dynamic. They, they report a one-shot ordering situation, whereas the dynamic inventory models place orders repeatedly over long periods of time. With that, we can go for a repetitive stream of orders for the same item placed over a time. The dynamic models are the primary focuses. The pure static case also is called one period model, even though under some circumstances a corrective, the second shot may be allowed. With that, the other static example, let us consider that the storekeeper who has to decide the how many Wall Street Journal's newspaper to buy for an each day. Only one decision can be made to buy n newspapers. In its purest form, there is no opportunity to correct that decision based on the latter information. So one more example is the problem of hot dog vendor at the ballpark. The dynamic situation requires different considerations because the demand for such item is to be constant. The orders are placed repeatedly over a time. The problem becomes one of adjusting inventory levels to balance the various costs so that the total variable costs are minimized. And the variable in this case means these cost changes with the order size. The service system uses many kinds of supplies with the demand dynamic patterns as of the hospitals, hotels and restaurants and parks, airlines and educational situations. The second one is demand distribution. The type of demand distribution is to classify in three types. One is certainty and risk and uncertainty. There are decision problems that have outcomes known with certainty. For example, signing a contract to supply a given number of units converts demand from a risk to certainty. The locating a supplier down the block reduces the delivery time is a uncertainty. Generally, there is a cost for certainty because the contract reduces the producer's risk. The buyer expects the price will reflect in the spec. The supplier that locates across the street from the buyer expects the compensation for being at that location. Sometimes the certainty is a reasonable assumption. This only works when the degree of variability will not affect the solution. Then certainty is assumed for convenience and it doesn't violate the spirit of the model. The LT for delivery is often treated in this way. Suppose that 2 weeks is the average LT for a specific case. The variability around the average will determine if 2 weeks can be used as if it were certain. It is important that users of inventory models know when the certainty assumptions are allowable. The uncertainty means that is no good forecast for the probabilities of demand or LT distributions. When uncertainty exists, the probabilities for various levels of demand occurring are speculative. However, there is a known risk. Some planning can be done. The delivery of critical materials from the poor port city of Koban in Japan always be totally reliable so that it is called a uncertainty. The order cancellations may be a less severe disaster, but they are usually costly enough to make planning for the event worthwhile. Many production departments have exposed to take the risk that an order in process will be cancelled. When the forecasting is difficult because there is no history, systems are developed to search for advance warning. They are turned into whomever might have information about orders. Every effort is made to find the key players who organize the orders and to keep them in the communication loop at all the times. The other factors that might be triggered into track the efforts are made to be gain some control over the uncertain circumstances. Next, the stability of demand distribution either by fixing or varying. The uncertainty about setting the right capacity of for supply includes the possibility that the demand distribution is changing over time. This could be caused by a stable shift factor such as seasonality. On the other words, the drivers of change could also be unknown. In the latter case, the instability of causal factor is generally acknowledged to reflect high risk. It is if it is known how demand is changing, then the risk levels may be controllable because forecasts of some merit are possible. The some of the methods OPP are applicable to predictable demand distributions. The best of these is stable demand, but forecasts can be modified if it is known how the distributions are changing. Otherwise, the system is searching in the dark. Other methods than OPP should be used to manage these situations. The best method is the material requirement planning (MRP) is the most favored alternative when the demand distribution is known or unstable. Next, demand continuity or smooth continuity. Much of the prior discussions which are applies to demand continuity. OPP needs demand continuity that can be described as persistence of the stable demand pattern over a relatively long time period. MRP is an alternative inventory methodology that can deal with the lack of smoothly continuous demand. It should be noted that assuming smooth and continuous demand is a key to converting a known risk situation into one of the certainty. The assumption is usually valid and can be tested by implementing different patterns that are more or less smooth and continuous and measuring the extra costs incurred for assuming perfect smoothness when in fact it is good but not the perfect. Such testing called sensitivity analysis is most readily done with the computer simulation programs. And lead time distribution and either may be fixed or variable. Lead time is the simply known as LT is the interval between order placement and acceptance. That is, order need recognition and the placement times are included. The validity of lead time will be a factor in setting the size of the buffer stock. As lead time gets longer, inventory systems become more sensitive to problems that can arise in the supply chain. One of the main reasons is that with the long lead times, the correction of errors takes longer. The more critical the materials are for production, the worse this situation becomes. For materials that are not critical, the assumption of the fixed lead times doesn't do too much damage. When materials are critical, inventory planning had best take into account the forecast for the lead time distribution. In that event, lead time distribution will assign additional units to buffer stocks. Another name for buffer stock is safety stock because these units are held to provide protection against variability in demand and lead times. In demand dependent or independent demand. The focus is now on independent demand systems. This means that orders can be placed for non-dependent items without considering the what demand is forecast for the end of the product for which that they are part. For example, the labels for a specific kind of jam and dependent on the demand for that particular kind of job. Beach plum jam is highly seasonable because of the nature of the crop, which doesn't meet the criteria for stable. The continuous demand that characterizes OPP models. Alternate to OPP should be used when the demand dependent systems are involved. This is applicable for the components and sub-assemblies that are used as part of one or more finished components that have sporadic demand. The dependency is greatest when both the timings and the quantity for end product demands are not predictable. So finally, these inventory situations will be occurred by who manages inventory, and management of inventory is a major responsibility. Then now how to manage inventory is depending on the type of inventory that is involved. Most type of inventory situations are best handled by well-designed computer systems that utilizes as much centralization of record keeping and order placement as is possible. The manifold advantage of the system's perspective with the centralized buying includes the fact that larger quantities provide stronger supplies relationships, bigger discounts, and a more informed choice of suppliers, and less chance for mistakes with respect to crucial factors either by price, quality, and reliability. Without the system's perspective, everyone everywhere will be ordering what they need as that they need it. The lack of coordination diminishes buying power and loses the knowledge based benefits of the centralized system. The strategic thinking is required to optimize the production plans of suppliers and producers to best meet the needs of the customers throughout the supply chain. In that way, the lowest cost and best deliveries can be achieved for mutual benefit. The information system of a multinational company with centralized inventory management system has to keep track globally of where everything is, where and when it will be needed, and when it will be reorder it, and where to store it. It is an enormous system to manage. The strategic thinking that went into designing any such system must be robust and not casual. The need for replanning is always be there when things to do work out on the planned. These concepts are fundamental to understanding how perpetual and periodical inventory systems the work and when each is preferred. The EOQ model providing further insight for inventory managers in situations where the discounts are offered to buy in the large quantities. So with that, what are the typical situations of inventory situations that we have discussed in the today's class? That is, one is order repetition either by static or dynamic situation. Second, demand distribution The demand may be certainty or risk or uncertainty. Based on that or accordingly, we have to respond for the inventory models. The stability of demand distribution, either by fixing or varying the demand. Then demand continuity, the smoothly continuous or sporadic and occurring as a lumpy demand, which is to be independent. And the lead time distributions is the interval between order placement and the order recipient. And dependent and independent demand, when components are dependent on one or more end items, the information system must be able to calculate the link demands. So with that, we have taken up the inventory situations. In the next class, we are going to discuss about the inventory related costs. There also how many costs are there and how a cost related to the inventory, and the core of inventory analysis will be by measuring the relevant cost will be there. So with that, we are closing this session. Thank you.